to explain such kind of problem. Hello, welcome. Let's try to solve another Leetcode problem 838, push dominoes. If you understand the problem, let me just try to explain it by using some examples, and then we're gonna simulate the problem, because I think simulation gonna be easier to understand and to solve. Yeah. So let's first try to understand some examples. We need to know that this is gonna be like a real situation. So in the real situations, the push domino is gonna be like that. It seems so in the example 2 from here, it seems from here there's gonna be a force. So for example here, force to the left side. Yeah. So it's gonna activate another one. So it's gonna fall to the left. And here there's a force to the right side. So it's gonna fall to the right. So this is to the left, and this is to the right, and this is to the left. Yeah. So there's only a condition. So if so, for example, this is a left and left, and this is a right and a right. So there are two left and two rights. But in the middle, there's still a dot. So if it is a dot, so it's gonna still be vertical. So it is exactly like the real situations. Yeah. Now let me make a drawing. Maybe we can try to understand it easier by with kind of a solution. We're gonna solve it. So we're gonna have two right and two dot, and we're gonna have one left. Maybe we're gonna have another dot. Yeah, let's just use a very simple example. So what's gonna happen is that, this is the right. It means there's a force to the right. Yeah, and this is the left. It means there's a force to the left. So what's gonna happen is, this dot is close to the left, right? Because the left is at its right side. Definitely there's a force coming here from the right to the left. Yeah, and this force, we call it left. So from the right to the left, there's a force to the left. So for this dot, we're going to check the distance to the right and to the left. If this distance to the R is more than the distance to the L, I mean it is closer to L. So for this dot, if it is closer to L, so first it will be activated by L. So this means it will fall to the left. Yeah, because this dot is close to the L. And there's a force to the L, because at the left side there's a force, and the right side there's a force. Yeah, but there will time coming to this dot. So we just need to compare which one is closer. Because it is close to the L, so we're gonna make this dot as L. And then we're gonna check this dot, if it is closer to the R or it is closer to the L. Of course it is closer to the R, so we're gonna make this dot as R and this dot as L. Yeah. Now the problem seems we just need to compare all the dots. If the dot is closer to the L or closer to the I, So for this dot, definitely from the right side, it has a distance of 2, and from the left side to the L, it has a distance of 1. So we're gonna have this dot, gonna become L. And for this dot, it has a distance of 1 from the right side to this R, and it has a distance from the 2, it has a distance of 1 to the left side with this force from R, and it has a distance of 2 from the right side with this force of L. So definitely we're gonna choose the close distance. So we're gonna choose this R. So at this dot, it's gonna become R. Yeah. So if we have this kind of intuition, basically we've already solved the problem. Yeah. So this means for each of the dot, we just need to compare if it is closer to the L or if it is closer to the R. So if it is closer to the R, so we're gonna record this dot as R. If it is closer to the L, we're gonna record this dot as L. So if it has the same distance, for example, in the middle, we have a same distance to R, it has a distance of 2, to L, it has a distance of 2. So for this dot, we're gonna keep it as a dot. Yeah. Maybe we're gonna check this dot here at the right side. So for this dot, what is the distance? What is the So for this dot, what is the distance to the r? Maybe we think maybe the distance to this r gonna be 1, 2, 3, 1, 2, 3, 4, but it is not like that, because there is a L. Because this L gonna influence the distance. Because you know here is a force to from the right side with this r, it gonna propagate. It's gonna propagate to the right side. But because of there is a L, it forces the propagation. So it means if there's a R and here is a L, it cannot go to this position. So it means the distance is not 4, but the distance is gonna become infinity. It means there is an infinite distance. Yeah, so we're gonna set it as infinity, or you can set it as because for this L, it has a distance of 0 to L itself. Maybe this R has a distance to R to 0 itself. So we will not use 0. So we're gonna use infinity. So this means for this dot, what is the distance to the right side to this R? What is the closest distance to the R? Yeah, because there is a L, it has influenced the distance. So we're gonna set it as infinity. Yeah. Now we knows how to basically we knows how to solve the problem. Yeah. First of all, we're gonna check from the left to the right side. So from the left to the right side, we're gonna have one loop, and let me just clear a little bit and try to simulate. So we have right, dot, dot, and left, and another dot. So for the first loop, we're gonna simulate it from the left to the right side. So from the left to the right side, we're gonna check the force from the force to the right. So this is a force to the right, and this is also a force to the right. So we're gonna have a record of the closest distance to the force of right. So for this dot, for this position, the closest distance to this R from the left side, it is this R, so it's going to be 0. And for this dot, this position, the closest distance to the right side, to the left side from the force R, including itself, it's going to be R itself. So it's going to be the distance going to be 0. What about this dot? So the closest distance to the R is going to be 1. And what about this dot? The closest distance to this R going to be 2. So what about this dot? So the closest distance. So for this dot, what is the closest distance to the right side? Because for here we will not use 3, because for here if we find a left, it means there will be no influence to the right force. Because if this is a left, if this board is slide or fall down to the left side, it can never rotate to the right side. Yeah, because it has already become the left side. So if we find a L, so what are we gonna do? We're gonna set it to infinity. Yeah, so if it is L, we're gonna set it to infinity. It means for this position, the distance, the influence of the distance to the R gonna be infinity. It means nearly it will have no influence. So what about this dot? Of course, this dot is gonna be infinity because there has already been a infinity. So we're gonna set it to be infinity, because there will be no influence to this R because there is a L. And of course for this L, the influence from the R gonna be infinity. It means there's nearly no influence. And then now we're gonna start the second loop. The second loop is gonna start from the right to the left side. So we're gonna check the influence from the L. Yeah, it means the force from the left side. So for this dot, is there any influence from the left side? So there's no L. So if there's no L, so what are we gonna do? So we're gonna set it to be infinity, right? Yeah. So what about this position? If this is L, what is the closest distance to L? So it is 0. What about here? The distance to L, it is 1. What about here? The distance to L is 2. What about here? The distance to L, it is not 3 because there is already R. If there is already R, it means for this board, it has already fall to the right side. It can never rotate to the left side. So we're gonna set it to be infinity, and this one we're gonna set it to be infinity as well. Yeah. Now the final one, we just need to check the two arrays. So for this array, we're gonna set it to be the right array, and this array we will call it the left array. We just need to compare if they are same, so it is a dot. So this one gonna be a dot. Yeah, because this one will fall to the left side. Of course, here gonna be a dot. Now we're gonna check the distance. So the distance to the r is infinity. It means there will be nearly no influence for this r. So if this r is more than L, this infinity is more than 0. So what are we gonna do? We're gonna keep it as L. So this is a dot and this is L. Yeah. And for this one, because the distance to r is 2, the distance to L is 1. So what are we gonna do? We're gonna keep it at L, and similarly here gonna be r. And here the distance to L is infinity, so we're gonna keep it as r. And the distance to L is infinity, the distance to r is 0. It means 0 has more influence, so it's gonna be r. So this is gonna be the final solution. It's gonna be r, 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 L, L, and dot. As you can see, this is gonna be r. So of course this dot is gonna be r, and this is L. Of course this dot is gonna be L, and there will be no influences. Of course this gonna still be the dot itself. So this is gonna be the final solution. So if you understand the simulation, now we can just start coding. Yeah. So we're gonna prepare the length of the dominoes. And now I want to prepare a right array and a left array. I'm gonna set it to be infinity times 0, and I'm gonna prepare a current. Yeah, because for the right array, I'm gonna loop through from the left to the right. So I'm gonna set infinity for the current position, and then I'm gonna loop through it. So for I, D, enumerate the dominoes array. I want to check the dominoes if it is R. I'm gonna set the current to be I. Yeah, because according to this current, I can check the distance. So the distance array gonna be the right array. So the right I gonna be it's gonna be the I minus this current. Yeah, because we just need to check the distance, it should be like this. So if this is R and if this is a dot, we just need to check the distance. Of course, this R, the current equals to I, this is 1, and this I equal to 2, 2 minus 1, so it is 1, so the distance is going to be 1. This is why we use I minus the current. Yeah, and if we need to check if this domino is left. So if it is left, we're gonna set the current directly to a negative infinity. We set it to be negative infinity because we're gonna use I minus this current, so it's gonna become positive infinity, because finally inside of the right array it's gonna always be positive infinity. Yeah. Now let's just copy the same code to simulate from the right to the left side. So from the right to the left, we're going to prepare a left array, and current we're going to set it to be infinity. And here we're going to change a little bit because from here we need to check from the right to the left side. So it's going to be a minus 1 with minus 1 and minus 1. So we first going to check this L. So if the dominoes I equal to the L, we're gonna set the current to I. And if the dominoes I equal to R, we're gonna set it to be infinity instead of negative infinity, because it's still it's exactly the opposite operation. Yeah, because if let me just prepare some drawing. Yeah, because if we go from the left to the right side, so for this current, for this domino I, if this domino I equals to R, yeah, so we're gonna set it to be we're gonna set the current to be infinity. So if it is equal to L, for example, it is here, it is L, this is L, so we're gonna set the current to I. Yeah, but the I gonna always be more than the current, because the I gonna always be less than the current, so we're gonna use the current minus I to check the distance. So here we just need to change current minus the I. Yeah. Now we have a and this array gonna be on the left array. Now we have the left array and we have the right array, and the right array is just the distance to the R, and the left array is just the distance to L, and finally we just need to check the get the final result. So it's going to be an empty string. We want to draw inside. It's going to be an array. We're going to draw it. If it is a dot, we want to check. So if it is a dot, if L equals to R, so we're gonna set it as a dot. Else we're gonna check maybe R, maybe L. Yeah. So if we would set it to be R, so it means the L should be more than R. Else it's gonna be L. And we need to check, and this for L, R in zip inside the left and the right array. Yeah. There's a lot of coding, but the idea is just the simulation. If we simulated right, basically, yeah, if everything is correct, I mean, we simulate from the left to the right, and we simulate from the right to the left. Basically, this simulation is just to check the sorted distance. It is like a prefix sum. Yeah, it is like a prefix sum, as you can see. For here, the right is like a prefix sum, and this left is also like a prefix sum, because definitely we are going to check the sorted distance to the L and the sorted distance to R. Yeah, let me just double check if everything is okay. And this is I minus current, and this is a current minus I, and this is infinity, and this current is going to be equal to I. And finally, we just need to check the final solution. Yeah. Now let me just submit it to check. Yeah, as you can see, it works. Now let me submit it. As you can see, it passed all testing cases, and it's pretty fast. Now let's analyze the time complexity a little bit. As you can see, this is just a for loop, another for loop, so the time complexity is O(n), and the space complexity is O(n) as well. Thank you for watching. See you next time.